What is the most used man-made material on Earth? You guessed right, it's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. Welcome to another episode of the Concrete Logic Podcast, and today I have Alex Hall with Concrete AI. Alex, could you share a little bit about yourself and your company?
Yeah, so Alex Hall, I'm the CEO of Concrete AI. It's a startup. The business has officially been going for around 18 months. I've been here in the seat since September of last year. The idea actually generated from two professors at the University of California in Los Angeles. At that time, I was working for one of the big cement companies, Holcim, and I was actually in a role where I was in charge of their ready-mix performance group. So, within that, obviously looking at all of our ready-mix plants across the US and looking for different opportunities to, figure out how we can enhance concrete. That was about 5-6 years ago when that happened, and I brought what these guys at the university were doing to the attention of our CEO at that time, and he was super interested and said, look, go and figure out what's going on, see if there's anything there for us. There was very clearly some opportunity for us, but I at that stage, unfortunately, not unfortunately, I left Holcim and went and ended up working for a construction company. The owner of that company was super interested in what we were doing as well. So he ended up sponsoring part of what was a consortium at UCLA that we remained involved with until basically just towards the end of COVID. And I kept my association with the university as a consequence through that. Fundamentally, what these guys were looking to do was thinking of concrete kind of like a cake mix. Make us real simple for the folks who don't understand how concrete and concrete design works. But is there a way that we can use artificial intelligence and specifically machine learning to take those ingredients of that cake and either make it as cost effective as possible? That was the original kind of focus. And then as times moved on, some things have become more of a focus for end users. And so we can actually say, how do we use artificial intelligence to make this concrete the same concrete we were looking for from a performance perspective? So same compressive strength at 1, 3, 7, 14, 28 days, same slump, same amount of air and train. So all the engineering characteristics are the same, but how can we maybe look at those ingredients a little differently and combine them in a way to either make it cheaper or have it with less CO2? So that's the fundamental premise of what the business is all about. In my time that I wasn't working directly with them, the guys at UCLA did a lot of work, got funding from the DOT, from the Department of Energy, and worked really hard in turning this into a product. And since I come on board, what we've basically done is we've licensed the technology from the university, so we have a license to use the technology, and we've now moved on into turning this into a product, so that it's actually now what we have is a software product where a ready-mix producer has got tons and tons of data. Think about all the millions of batch tickets and various data points that they have, and what we allow them to do is to use our interfaces to connect back into their data, and then ultimately give them the power over their own data, all the different test results, all the different physical, chemical properties and ingredients of the raw materials, and use that data to figure out how to reformulate the concrete.
Yeah. So many questions within that. Alex. First off, if we could take a step back, for
Sure.
folks that like myself, I know just enough about artificial intelligence to be dangerous. I think what the movie Terminator, there was Skynet or something like that, and I think there's a lot of fear mongering out there. I guess there's really two sides, and that's there's a lot of this going on in the world over all spectrums of life right now, but there seems to be two sides to artificial intelligence. There's the side that says they're totally gung-ho about it. This is the future. This is going to solve a lot of problems. And then there's the other side saying, hey, we're going to create these robots that are going to take over human civilization, and we're all going to be screwed. So could you share a little bit about, because you're coming from the material side, what it sounds like was the majority of your career. So I'm sure until you saw the technology and what it was doing, I'm sure you had your thoughts on what artificial intelligence is. Could you just talk about how you learned about what it is and kind of explain what it is, and how you got to today where you're a proponent of this software?
Yeah. So I think one of the most important things, and I think you identified it, is you got to know what you don't know, right? So I was fortunate in my previous role that as long as you were inquisitive, the guy that we worked for was he also wanted to know more. So he actually ended up sending me off to MIT, and I spent a couple of weeks there on a program finding out all about AI and what it's all about, what its different applications are. I think what people, everyone kind of thinks, you hear the term AI and you bucket it, and what you actually got to do is you got to unbucket it, because there are multiple different kinds of artificial intelligence. So think of things like 3D printing, right? That whole robotics arm is one form of artificial intelligence. You then have things like Siri, right? So that's another kind, and that's all like natural language programming. It's a different bucket. You then have things like Google Maps and all various different types of artificial intelligence. Artificial intelligence is around us 24/7 today. Whether people like it or not, it's there. I think what you got to really be aware of is as a human, how do we engage with this artificial intelligence? And certainly for the short term, how do we use it to our benefit? At some point, yes, it's absolutely going to have a detrimental impact on some people's lives. There's some jobs that are probably going to go away from it. But the way we look at it, the one thing artificial intelligence does, and certainly the branch that we're involved in. So we're involved in a branch that's known as machine learning. And we actually, if you really want to start getting technical, we deal with things called neural networks. And neural networks are fundamentally, it's linear algebra. And I'm going to stop there. I don't want to go further into that kind of detail. What we think, though, what's really important is to understand that in our world, the artificial intelligence can bring huge value in processing. So just crunching numbers, doing multiple transactions and doing calculations. But concrete is a unique product because it's placed at a certain day and a certain time, and there are going to be certain elements that we need to be aware of that the artificial intelligence may not be aware of. So for us, it's really important to think about the incredibly important component that a human being brings to the discussion, and that's judgment. Now, AI doesn't have judgment. It makes a whole lot of permutations and will say, hey, this is what I think the best case scenario is. But in reality, we know that when clients have given us a mixed design to go and optimize, and let's say, for example, it's someone wants a really high early strength concrete. So they want, let's say 8,000 PSI, 28 days, but they really want 3,000 or 2,500 PSI within 24 hours, right? And we go to the AI and we give it all these parameters and say, right, go ahead and optimize it. And optimize it for cost. the AI will give you a number, but then if I'm a designer and I look at it, I go, really, I'm really uncomfortable having less than 50% OPC, because I know how critically important it is to get to that 2,500 PSI within 24 hours, as an example, right? So this is where we go a little bit different. We actually allow the human to come back and make certain adjustments and constraint controls. So they can actually then say, also, by the way, I'm in Chicago. I'm really worried that in 24 hours time, it's going to be super cold. It's going to have an impact on the set rate. How do I make that adjustment over and above what the artificial intelligence has done, and take those kind of things into account? Are we going to get AI that knows what the weather's like in 24 hours? Yeah, absolutely. These kind of things happen. But for right now, today, what we got to do is we got to give the human being the ability to influence things by applying their own judgment. So I'm a proponent of AI. Absolutely. I think beyond what we're seeing with where the self-driving cars can go, I think I was heavily involved in health and safety in my previous companies as well, and I think the evidence is there that the benefit of having a autonomous driving car, where you have, even in the presence of humans, is undeniably better from a safety perspective. It's out there for everyone to see. Are incidents going to happen? Are mistakes going to happen? Absolutely, but they'll probably happen at a way lower rate than a human. And you don't see too many drunk drivers that are the form of autonomous vehicles. That just doesn't exist. May they have a bug? Yeah, for sure. These things can happen, but I think relative to the risk that humans in the same situation would pose, not too much. So, could something go wrong? Sure, absolutely. Is it perfect? Absolutely not. But is it better than what we have? I think it is.
Gotcha. Yeah. So to create this software, I'm just guessing here,
Sure.
but did you all take, like you were sharing before we hit record, was a bunch of batch tickets? Think about how many of those are throughout the country, and So did you take, like, to create this thing? And I understand you can only share so much, but is you essentially have a mixed design, and then there's a kind of a probability of what that performance is on the other side of things, and that's what's inside the software, and it's in there, infinite amount of times in there, way more data than human can comprehend, right? That's the basis of it.
Yeah, so there's two things, right? You've got to differentiate the software, which is what we interface with, you and I, like even the software we're using right now in this video chat's its own kind of software, right? But then there are the models, and the models are where the magic happens, and those are basically algorithms that sit in a series of servers, and it's where all the processing of the data happens. So we use the software to tell the algorithms, hey, this is what we want, and then we send that information down to them, and they go process it. To actually answer your question, we've got probably close to 800,000 unique different data points, and then when we talk about data points, it's actually a whole lot of different data points. It's mixed design A. Let's say there's 6 to 10 different raw materials in there. So, cement, sand, aggregate, all the different chemical admixtures. And then there's a couple of layers of data within that. So now we also need to understand chemical and physical properties of the cement, right? So we get all the various ASTM, like the C150 report around the cement. So think of a cement, I don't know how familiar you are with like a cement mill certificate and all the information that's contained in that, right? So there's more layers of data that's beyond just the cement and the type of cement we're using, all the physical chemical properties as well. Same thing we look at on the aggregate. So on the aggregate, we look at a thing called the C33. And the C33 race basically is giving us an indication for that specific product. These are all the different gradations that we can expect, okay, and actual representative sample of the product. What's important is that these things change, right? These are raw materials. So you can be mining a quarry and literally move 25 yards to the right, and there's a little difference in terms of the setup. Who knows? Maybe the jaw's a little bit out of alignment, and it becomes a little bit more flaky. How do you take these things into account? And that's why for us it's really important that we can keep on feeding new data into the models, and on the basis of the new models, the new data, start getting better predictions. So just the way you got to kind of think about it, it's got layers and layers and layers of data that we can then reference against previous performance. And so how it works with us is when a client gives us a mix design to optimize, they say, these are all the raw materials I have available at my plant. This is the current design I'm using to generate this output. We then go ahead, use our software to interface with the algorithm, do the optimization, kick them back a new design configuration. We then predict what that's going to do, again, from a engineering perspective. What compressive strength is it going to get to, 1, 3, 7, 14, 28, 56, 90 days. We predict what the slump is going to be. We predict what part diameter we can actually pump this thing through, and then also how much air is going to be entrained in this mix. So all those kind of parameters. Flexural strength, that's another one we can give it. And then on the basis of that, we say, right, let's go do a lab test. And we then go ahead, they go and make that same mix in a lab, do the normal slump testing, and then we'll do breaks at whatever time period they're looking to do. And then, within 30 days, we can go and do the same thing and trial it at a plant. And been really happy with the results. We've completed multiple, we're onto our fourth pilot with clients at the moment. At this point in time, we actually have commercial agreements in place with multiple different kinds of parties. Some people are property developers, other people are actually ready-mix companies, and they're starting to deploy the technology and put it into production. So we back up what we say, right? If we want people to make sure that they're happy with the quality of the concrete that's going out there in the first place, and at the same time meeting their expectations, whether it's on a cost-saving perspective or a CO2 reduction perspective, or both.
Okay. Yeah, so you got a mix of clients, it sounds like. So you said developers and ready-mix suppliers. Any structural engineers in there as well, or you? No.
No, that's a tough look. At the end of the day, we're a business, right? We've got to pay for ourselves, so we also got to figure out what does that model look like for how we stay in business.
Yeah.
And it's tough. Obviously, we work with a lot of structural engineers. They're people that have to look at it and approve the product at the end of the day. And certainly for our clients that are property developers, a lot of them have, the ones we work with have in-house engineering capability. So we work with those folks in those roles directly.
I gotcha. So it just popped in my head. Is this a replacement for a structural engineer?
No, again, because this is the important part about what we do, right? We don't look at this as, the way you got to think about this is, I'm going to steal a phrase here, but it's algorithmic business thinking. You bring the algorithm in, but you've got to let the human apply the judgment. AI will give you a prediction and a probability, but it can't provide judgment. Judgment is a unique human characteristic that AI, to some extent will have. But it's still something that you need a human with a human's unique experience and honestly a human's unique purview. You got quality control people that have been doing this job for decades that, they know what's going to happen in 2-3 weeks time. Oh, guess what? RDOT are going to go and start icing the roads, right? Or de-icing the roads. What do we have to think about then? Because that's not the same concrete that I poured 6 weeks ago. We got to figure out what that's going to look like when those kind of things.
Right. Yeah, I was thinking because kind of what goes on now is a concrete contractor will call into a ready-mix supplier, to a dispatcher, and say, this is the mix design I want, and then they'll do what they think is right based on what's the weather or where they're pouring, like you shared before, if they're pumping the concrete, that superintendent that calls in to the ready mix supplier, he's making all those decisions, typically the day before a pour. So if you had a software that I guess could, put the current conditions, in that, if you could put the current conditions in that software and it could automatically just tell you what this is the solution, that just makes a whole lot of sense. That takes the human error out of the equation. As long as they're putting in the right, the right conditions, what they're actually doing. So that they got to say, hey, the sun is shining, the wind is blowing this much. I'm pumping through a 6-inch hose, 5-inch hose, whatever it is. And as long as all that data goes in there correctly, I'm thinking this is the machine or the software tells you, hey, this is the ideal mix design based on what you have. And before we go further, I'm assuming the processes of getting approved submittals and everything, that point that still remains all the same. You're just dealing with the yeah.
Absolutely has to. And again, so it's new software. So the one thing we keep on doing is our software team keeps on working on adding these kind of features. So like when you got to have a submittal and you got to make a submittal, you want to make sure that's presented to an engineer in a way they can digest it. And then, many times, what they kind of getting used to now in some cases is the fact that there is this prediction capability. That fundamentally at the end of the day, the underlying models are all mathematically derived bases, right? So this is something that appeals to engineers typically because you can demonstrate the science behind an output. The one reality though, and think about why we have over design, is because we make mixed designs in a kind of a sterile environment with not too many exterior effects. So while they have the 1200 psi over design, is because you don't know what conditions you're going to be coming up with, no matter what the operating environment is. So again, that's the one thing we don't want to mess with. We include that. We're not taking the risk out of it. We want to keep that risk factor in there. So we still maintain the over design characteristic within the concrete. But even doing so, there's a lot of opportunity to get a lot better at these things. I mean, concrete mix design historically has been experimental. People will, I'm going to try this mix here, and then 28 days later, this is what I get. And if it meets the criteria, okay, great, move on. We've achieved it, but kind of stops there because it's an expensive process. I mean, just to put together one mix design and go and test it, by the time all is said and done, if you take into account the quality control technician that's gone and made it, the getting the materials to a site, the time it takes to mix and cure all these things. Mix design on its own, probably somewhere in the region, depending on how big your operation is and how many you're putting through, it's probably around $400 to $600 every time you want to go and do that. And that's being super conservative.
Yeah. No, it's it's a lot. It's a lot to data to deal with. I don't think people truly appreciate the day in, day out of ready mix suppliers and concrete contractors, what they go through, and all the material suppliers. I mean, when things go sideways on a job, everyone gets pulled in, and I think I used this term before, but it's basically a witch hunt on who's to blame when things go bad, and that's kind of the reason why things are over designed, right? Because the engineers are like, hey, I don't want to be part of that, and don't want to be part of some, God forbid something catastrophic happens because of poor mix designs. I mean, in the past, people have been killed because of not necessarily poor design, but just poor processes and procedures and doing concrete. But what really appeals to me, Alex, of what you guys are doing is the making sure that we are putting local data into this software, that kind of information versus doing a blanket across. I guess, yeah. So, if I'm pouring concrete in Virginia Beach, Virginia, it's totally different than pouring in LA, right? You're using totally different types of material. So it drives me crazy when I hear people in our country say that, hey, this is the solution for everyone across the country. Doesn't matter where you're at, what climate it is, what time of day it is. This is the end all. This is the end all solution. I'm like,
no, absolutely.
Yeah.
Dream on. I mean, the reality of so think about concrete. Concrete's the most consumed product in the world after water, right? But every single ingredient in concrete is effectively a commodity. The cement producers never want to hear that their product's a commodity, but really, I mean, it is. At the end of the day, pound per PSI, there's not much difference between a class 1 from producer A and producer B, right? It's the same thing. The only thing that differentiates them ultimately is how much it costs to produce. And a mega plant that's doing 4 million tons of clinker is definitely going to be a lot cheaper than one that's only doing 300,000 tons of clinker a year, right? So that cost differential, and then the cost of distribution. These are commodities. I mean, think of aggregate, right? And then just use a round number. $30 a ton is probably typical from what we've seen delivered. What product on this planet costs $30 a ton? I mean, it's ludicrous, right? I've had the benefit of running aggregate operations in South Africa and here, and I know how much work goes into doing that. And I find it really tough to believe that we're only paying $30 a ton for that material. I mean, you got to get it out of the ground. So typically using chemical energy to blow that up. You then got to put it into a dump truck, take it to a primary crusher. That's you probably got 100 amp circuit breakers minimum on the smallest ones. I mean, there's so much energy and processing and capital that goes into it. But we sell enough volume to make it up. And so when you look at concrete, every single one of those materials, and obviously the chemical admixtures are a tiny component of that, so maybe not so much of a commodity. But these things are local. These are all locally sourced from the local market. That's just the reality. And think about concrete. A concrete producer, the worst thing they can ever have, right, is a stock out. They've got a C33 sand, they meet the DOT spec, and all of a sudden they can't get it. It's not that the sand and gravel producers want to do that. These things happen. Plants go down, and people like living on the edge in terms of supplying materials. So again, one of the challenges is what happens when I don't have that, and I can't wait another 33 days to go and figure out what that mix design looks like. But if you've got enough of that data of the relevant products, you can actually use your own data from the material supplier and apply it to this kind of technology and get a solution relatively quickly that is going to be damn close to satisfying exactly what you need. It might be a couple of bucks more expensive, and that's the price you're going to have to pay. But you're not going to have to wait 33 days to go and make a new mix design. You can be real close and add an additional factor of safety and at least keep your customer at the end of the day happy. Because at the end of the day, that's construction, right? Time, value, and money, man. Get that building up, get it up quick, because the quicker that building's up, the quicker it's got tenants in, and the quicker it starts generating a return for us.
Yeah. So it sounds like basically you're trying to optimize what resources are available to, that particular project. And doing so, I imagine, and it mentions on your website, but that our favorite topic on this podcast recently is talking about CO2. So I'm sure just optimizing a mix design, you're reducing the CO2, be it reducing the amount of cement or the other materials that they're shipped to which people seem to forget that everything that's sent to a ready mix supplier is on a truck, and that truck is running on diesel, and diesel emits CO2. Sure. But we're not tracking that. But anyways,
no, we are. I'm
sure you guys are, but I'm saying I'm generalizing. I'm sorry, Alex. I'm generalizing.
Yeah.
I feel terrible for our cement folks out there that I feel like they're getting picked on, and there's just so many nuances to concrete. There's other things out there, and even other building materials that we seem to just overlook, and we just concentrate on the cement. But
Seth, you say that, but it's real, right? Like if I don't think it's something we have to avoid. This is a conversation that cement producers are mature enough that they have to face. When you look at all those ingredients, right? You look at a ton of cement, and if we just use the PCA numbers right now, PCA will say that for every ton of cement we produce, I think the number they use right now is 400. I've got to talk metric because unfortunately the whole climate economy is all in metric units. But for every ton of cement you produce, so 2,206 pounds, 1 ton, 1,000 kilograms, they say a class 1 cement will liberate 468 kilograms of CO2. Okay. Fly ash is a waste product. So if you take cement substitution and you substitute cement with fly ash, you probably take that number down to somewhere around 50 or 60 kilograms. So 1/40th, roughly, the amount of CO2 that cement has. So they're not getting picked on. Believe me, the steel industry is worse. So you look at a ton of steel, there's way more CO2, but you don't use a ton of steel relative to cement. It's just it's a numbers game, and it's a volume game. There's 4.2 billion tons of cement that are produced a year. 4.2 billion. I mean, people can't even rack their head around that. That means there's probably around at least 30 billion tons of concrete that are made on this planet every year. It's a big number, and it's a big impact. I mean, if the cement industry were a country, they'd be bigger than France in terms of the amount of CO2 they put out. It's massive. You just can't ignore it. It's
no,
there. And it's an opportunity.
Yeah, no, I'm not saying we should ignore it, but at the same time, we got to be careful on how we plan on to. I don't want to say the word attack, but I guess to respond to that criticism. Because I think technologies like this too, because we're so focused on the United States and what the United States is doing, and how much cement they produce, how much concrete they produce, blah 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 blah. But I think what we got to look at too is that not only how we produce concrete and cement here, and I would say the Western European nations, but also look at the emerging countries that produce cement as well, because they're doing it old school. They're doing it like we did 40 years ago. So if you look at where where most of the CO2 emissions come from our industry, it's not from us. But we got to lead. Like you said, we can't ignore it. We got to lead the way. And I think what we're doing is, and you can correct me, Alex, I don't feel like we're helping those folks out, those emerging countries that use concrete. Because I read something crazy, and I don't know if you've seen this as well, but China used as much concrete in 3 years that took the United States using 100 years. That was like 17, 18, 19, I think, was those booming years for China. And they just were off the chart as far as producing cement. And guess what? Their energy technology is 40 years behind us. They are not using anything close to us as far as, they use way more coal and things like that than we do. So helping those folks out see the light, I think, is something we need to make an effort as well.
So I'm going to correct you on one.
Okay.
I actually think we are already helping, because the reason people look to the US is because this is a country of solution providers. and we're already providing some of the solutions to the problems. The most efficient cement plants in the world are in the US. I mean, have a look. Wholesome have got a plant, St. Genevieve. Technology marvel. I think that plant has maybe 236 people. A plant that puts out the same production in India has got almost 10,000 people. So people look to America to provide solutions, and this is honestly, it's part of why this kind of company even exists, is because the startup infrastructure and ecosystem and the way we integrate with academia, and we get facilitated in this country. Just anecdotally, it's kind of interesting. How many tons of cement in the US what do you think we produce a year?
I have no idea.
It's around call it 100 million tons in the US. That's production with imports and stuff. I think it's closer to 110, 112 cement, right? How much in China?
It's got to be I don't know, but I would guess 10 times that.
Yeah,
20 times that. Yeah.
It's 2.7 billion tons. India, interesting enough, is probably around 800 million tons, so probably 8 times more cement. But if you have a look at their economy and you have a look at so one of the interesting metrics is where does the cement go, right? So in the US, 75 to 80% of the cement goes to ready mix, right? About I think 7 or 8% goes to precast, and then there's soil stabilization, all those kind of things. But in India, it's the opposite, right? Most of their cement sales are in bags, right? Not bulk. So a totally different way things are done. But interestingly enough, people always argue about the quality, and at the end of the day, what's really important with cement is bang for your my buck, right? So for a pound of cement, how many PSI am I going to get? That's an important metric, right, from a performance perspective. And so there's always questions around that and how good, relatively speaking, some cements are comparatively to others and how consistent they are. But I was at a conference in Dubai in September, and one of the guys from an Indian operation actually presented, and their cement that they've had tested through on an international standard had less than 500 kilograms of CO2 per ton, which is basically, I think it was a type 2, but I mean, again, so just trying to put things in perspective. These folks are catching up, and they're catching up really quickly. But your point's a really important one. You got to remember that cement consumption is critical for welfare and for well-being. If you think of infrastructure, whether it's a sewage plant or stormwater pipes or hospitals, these aren't steel structures, right? These are concrete structures. These are cost-effective infrastructure that comes as a result of the product that we're involved with. And all these developing countries have got the two big ones have got far bigger populations than the US, but the GDP per capita is way less. But the way out of poverty is by investing in these kind of technologies that extend life, that extend quality of life, and they need concrete. They are going to need concrete. And the reality is this number is only going to get bigger. It's not going to get smaller. So what we're doing is saying, right, today what we can do is we can help by using less cement. And we know that we can already help people use less cement. And if there's substitutes available, whether it's fly ash or slag, we can help people incorporate that more and reduce the cement to an even and lower extent. But I don't know what the future looks like. I mean, we're already starting to play with other cement substitutes. We signed an agreement recently with a provider that's going to give us access to a different cement substitute. It's a little bit expensive at the moment, but once these things start getting manufactured at scale, it's going to be really interesting, because I can see in maybe 5 or 10 years' time, some of these products that we actually start seeing CO2 being consumed in the manufacturing process. It's crazy. If you get a chance, there's actually a really interesting block company. It's called Carbon Built. And these guys actually inject the block with CO2, and it absorbs the CO2 at a pretty significant scale. Like, I mean, in some of these blocks, there's like half a pound of that block is actually CO2 that's being captured. And look, I don't know if we can do that at scale at ReadyMix. The technologies that are there at the moment aren't doing removal at that kind of scale, but it's interesting. This stuff's coming, and it's coming quickly. And the other thing is there's economic value in this for the producer as well. There really should be a green premium, because there truly is a cost to carbon. Carbon removal credits right now, the cheapest ones I've seen are $260 a ton to remove CO2. The avoidance, that's a lot less. If you on a regulated market, California is close to $30 a ton. Europe on avoidance is a little over €80. So there's definitely economic opportunity if people start thinking about this, and concrete producers need to think about, hey, what's a green premium we could be charging, because they should be recovering in this. The technology is giving people benefit. It's using less CO2. Why not get rewarded for that?
Yeah, I could talk to you for another 2 hours about carbon credits. I heard something very actually interesting yesterday, but if you don't mind, I'm going to reach back out to you and get you back on the podcast. But for today, I think that's a good a good introduction to concrete AI. I appreciate your time today, Alex. If folks want to reach out to you and learn more about you and concrete AI, what's the best way?
Just contact at concrete.ai.
Yeah, and I'll put the link in the show notes when we put this thing out. And Alex, I appreciate your time. I'm excited to see what this is.
Anytime.
Like I said, there's much more I want to talk to you about, but I want to be short on your time. So appreciate it, Alex.
Appreciate it. All the best. Take care, Seth. Cheers.
Thank you for joining us for another Concrete Logic podcast episode. If you got some value out of this or you enjoyed it, please share it with others. And if you could take a moment and give us a 5-star review on your favorite podcast listening app, I would appreciate it. We will catch you on the next episode. And now Mike Dunton's going to take us out.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. Work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to